Holla, holla, back Mindsets. It is term 3. I hope you guys are up and ready for it because we are ready with a bang this term. I'm sure that, guys, if you didn't perform well last term, you've still have got this chance to perform better this term with us as Mindset. My name is Abram, and I do have Wilson with me to help you guys. Wilson, how's it?
Great, a new album. Are you
Awesome.
well?
It's a new term. How do you feel?
Great, I feel so great. Actually, I was not on holiday. Still going on holiday in 2 weeks'
None
time.
of us were on holiday because we've been revising.
We've been working,
Working.
Yeah, pushing hard.
But that's nice because we were learning and playing at the same time because we've got a lot of things that are happening around. But I hope you enjoyed your working kind of / holiday.
Definitely.
Nice one. You looking forward to this term?
I'm looking forward to this term, guys, and I hope you'll start this term with a bang, like what you said, Abram.
Yeah.
Okay. If you don't,
yeah, I'd love to hear from the Mindsetters. We've been helping them last term. I want to know how did they do on their mathematics. So, guys, do share with me on the page if you got 90%, 89, or not 70, guys, just 80 upwards. Because I trust you guys. I believe in you guys. But what are we doing today?
Great. I've revision, guys. Grade 11 revision, functions, a bit of nature rules, and a bit of trigonometry and coordinate geometry, guys. And I hope you're ready out there. You're going to try hard. And this is a new term, and you start strong. How you start is very important, guys. It doesn't matter what you got last term. You can change this. And how do you change this? By working hard, putting a little bit extra effort. You can't change situation if you don't put effort, okay? This is what you're going to do this time. You push hard, and you work hard, you'll change your circumstances, Abram. Okay.
Nice one.
Yeah.
Well, guys, before we get to the challenge question, let me tell you that you need to interact with us on facebook.com/learnextra. You should be knowing it by now. Like the page, share the page, and tell all your friends, your classmates, and go straight to your teacher and also tell them to like our page. Help one another also on the page because that's what we encourage, guys. The spirit of Mindset is #walk together. But also on Twitter, you can follow us at LearnExtra. We do have notes for you guys, the viewing and the download. Already they are posted on the page, so get on them. We have the test yourself as well. On the test yourself question, if you get those questions correct, all of them correct, you get this. You stand a chance of winning this. A Casio calculator, proudly sponsored by Casio. Well, the competition is closing to next week on Monday at 8 a.m. So guys, you've got the whole week to do the test yourself questions, but otherwise, tell us about the challenge question, sir.
Okay, great, guys. Let's look at the challenge question. Let's see what I have here. And you're going to try this question on your own. You're going to try hard. You're going to work hard on this. Let's see what I have. We have Sn equals to 2n cubed minus 3n squared. And be careful here. The Sn means the sum of the term. Okay? Then what you have to do here is find the first 3 term of the sequence is what you have. You have to find the first 3 term of the sequence. Then after finding the first 3 term, be careful, the first 3 term of a sequence. But this formulas, because this is Sn, denote the sum of the term. Implies if you substitute 1, you get the sum, not the term. So, but find the first 3 terms of the sequence. Then B, find the formula for the nth term of the sequence. The nth term of the sequence in A, guys. I think what we will do now, I'm going to give you time, guys, to go through this challenge question and try this challenge question, and we'll come back later and do the challenge question. Over to you, Abram.
Nice one. Well, guys, you've heard it. We're doing things differently since it's the first show, guys. We know that you guys need to relax a bit because you're from the holiday. So take the notes of the challenge question and start doing it. We'll see you after the break. Welcome back, awesome Mindsetters, and we just apologize a bit. We're having some technical problems which we're trying to fix, but otherwise learning still continue because you do have the notes that are posted for you guys. The links are on facebook.com/learnextra. You can still do the work in the meantime. Bro Wilson, I have this awesome question for you from the Mindsetters. There's a Mindsetter by the name of Nkosinathi Kolani. He says, why are we still doing grade 11 June work?
Why still doing
last term's work? Why are we revising last term's work while we are in a new term?
I mean, some of you are writing exam. You have your matric, they have prelim, which you write in June. I think preparation is very important. I mean, we can't study the whole year and rock up October, November and just write an exam. That's not really good. So you really have to practice, test yourself and see where you stand in terms of mathematics. And one can say, how do you really study this maths? Do you just look at the question and like you study business science or geography? I think with maths is practice, look at the example, do it again and try it. And so I think the junior exam, I mean, it's just to challenge yourself, see where you stand, and just go back maybe and work a little bit. Yeah.
It's not a mere effect of scaring you guys also, I think, because some think, well, I failed my test, so why are we still doing that? But I think it is also to challenge you to say, whenever you've done some work, go back, revise, and then it could also help you in the future, because what you've learned last term, it's also important also in this term. It's carrying on. It's never just a work for a term and then it ends there.
Yeah, true.
Right. Remember, guys, we do have the mobile mathematics, the Nokia mobile mathematics, whereby if you go to moremaths.org, you could also use the code, which is 0JRN, as the grade 11 mindsetter. Challenge yourself and see how you rank with other mindsetters and compared to other mindsetters. But now, more exciting news and giveaways. We've got this exciting competition. It is a serious water game competition. It is called Water Game. All you need to do is to register on watergame.co.za and also on Twitter and Facebook, hashtag #SAWaterGame. What happens is we're trying to raise awareness on water conservation and also trying to teach the mindsetters while they are playing. Great. So it's a game at the same time, we are learning at the same time. The prizes, we've got the first prize, it's a prize, it's money. Yeah, we're giving you, if you become the first person to win, it's 5,000 Rand for the first person. Second person gets 3,000 Rand, and the last person, I think we should give you 2,000 Rand. We'll give you 2,000 Rand. So guys, there's money involved, but there's learning also involved, because we'd like to help you guys. But I think we should take another ad break since we're still trying to fix. Oh, I think we're up already. We sorted. But let's take an ad break, guys. We'll see you after this short ad break. Welcome back, Prematrix. But as you all know, guys, we're sorry that we had a technical error, but now it's all sorted, guys. Let learning begin. We sincerely apologize for that.
Okay, thank you guys, and thanks guys for your patience, for waiting there. Let's see what we have here. I'll start with the first question, which is an exponents there. So what we have here is, given this 5 to the power minus x, express the following in terms of m. Actually, there's something missing. This is equal to m. So what we have here is, we have that this is the same, is equal to m, then express the following in terms of m. Can you see that? 5 to the negative 1, which is there 5 to the negative 1, 5 to the negative x is equal to x, is equals to m, then express the following in terms of m. How can I approach this problem? What I will do, I'll try simplify the expression and see what I get. How can I simplify this? What I can do, I can break this down, which is 2 to the x minus, what I'll do is 2 to the x times 2 to the negative 1 plus 2 to the x times 2 to the 1. I'm just splitting the exponents. Okay, then the next step, remember this is the same as m. Then what I can do now, I can split this, which is 5, and 10s prime is 5 times 2. Then I'll have 2 to the x times 5 to the x. This is what I get. Remember, this is exponential expression. I cannot move the terms, minus, base, and so on. You can do that if you have multiplication everywhere. Since I have addition between the terms, I cannot use same base, add exponents, minus exponents because of this addition between the terms. So what I can do is to factorize. Then if you factorize, look, what is your common factor? Common factor here, there's a common factor, and this is what is common between the whole thing. So pull out your common factor. If I pull my common factor, I get 2 to the x, bracket, 2 to the negative 1, plus 2 to the 1 over. I pull 2 to the x again. If I pull 2 to the x, I'll have 5 and times 5 to the x. Then from there, I can cancel the 2. Then let's see what we have. Then from there, what you have is that you'll have this. I can write as a positive exponent, which is 2, 1 over 2, plus 2 over 5 times 5 to the x. Then from there, remember that we've been given this, that we're given this 5 to the, Abram, they have this notes on Facebook, yeah?
Yeah.
So if you check on your Facebook, you have that something which is omitted that's missing, that 5 to the negative x is 10m, not m actually, it's 10m. This is 10m. So then now you have to write the whole expression in terms of m. Then from there, what can I do? I can simplify and I can multiply by my LCD is 2. Then I can rewrite this 2 as the same as 4 over 2 because I want to add the 2 fractions. If I add the 2 fractions, then I get 5 over 2 over 5 times 5 to the x. Then from there, what you can do is a bit of algebra. You can tip in times is 5 over 2 times, what do you get? 1 over 5 times 5 to the x. And what will happen here is that this cancel that. Then what do we have? Then what do we have here is that we have 5 over 2 times, I can rewrite this as 5 to the negative x, which is the same as what? We had this as 10m. Then your answer, you can go straight away and say this is 5 over 2 times 10m, because this was given as 10m, and we have to rewrite the expression as 10, as m. Then from there, what you can do, you can simplify, and this is 50. See what we have there. So this is 50 m over 2, which is 25, m. Great, fantastic. I hope you understand the problem. What we had here is an exponential expression, and given that 5 to the negative x is 10m, and rewrite the whole expression in terms of m. What I did, I simplified the expression, then until I get this in the simplest form, then I can substitute 5 to the negative x. Okay, great, fantastic. Let's see what we have. The next question here. What we have here, I like this. Show that the roots of x squared plus 2ax plus 3a squared are non-real for all a in R, and a can be 0. So what do you have here is to show that the roots of this are non-real. Which chapter of math is that? Nature of roots. In nature of roots, what do you do? What do you think about? Your delta. Where do I get this delta? From the quadratic formula. Underneath the quadratic formula, which is b squared minus 4ac. I have to find the delta. Okay, so we have to show that the roots of these expressions are non-real. So what you can do is that I can try and find, let me write delta, which is the discriminant, which is b squared minus 4ac. I have to substitute everything. Now, what is the b? What is b? Remember, b is the coefficient of x, which is 2a. So I'll have 2a squared minus 4. What is this a? It's the coefficient of x, and the coefficient of x in this case is 1. The c value is the constant. Why say this is a constant? Some of you might think 3a is not a constant because a is a variable, therefore 3a is not a constant. But this is a quadratic expression where is a function of x in this case, x squared, so we're working with x. So everything which is not x is a constant in this case. Okay, so my c is 3a squared. I can do my algebra here, simplify this, we get 4a squared. It's very important. When you square that and that. You can't write 2a squared there. You have to square both. Okay, then the next one, if I times this whole thing, I'll get minus 12a squared. Then I minus the 2. If I minus this, I'll get minus 8a squared. And what I can say from there, guys, what do you see there? We have our discriminant as minus 8a squared. And I can conclude therefore and say, therefore, delta is less than 0, which means the roots are non-real. To prove that the roots are non-real is to show that the discriminant is what? Is negative, which is less than 0. Therefore, the roots are non-real. Fantastic, guys. I hope you're enjoying this. Great, fantastic. Let's see the next question. What do we have there? Okay, next question. Great, I love trigonometry. I love trig. I mean, and to get trig right, you practice again. You practice, you never look at the sum and say, you know what, it will solve itself. You try and you do it. You have an example, you rather copy that example again. Just recopy the example, okay? And try it practice. Let's see what we have. I love reduction. Grade 11. 60% of your paper 2 next year is grade 11 trigonometry. And you rather work hard on your trig. And most students say, no, I find trig difficult. You know what? Practice, make perfect. Let's see what I have here. I have cos of 150 degrees. And if you see that, simplify without using a calculator. Can I just take this whole thing on my calculator and put cos 150, and because I do have everything, put cos 150 and bracket times tan, which is, where's tan? Tan 225, bracket, then over this and say equal to. Yes, that's correct, but what are we saying? Without using a calculator, you can't put this expression on the calculator and say equal and get your answer. You get your final answer. And for me, I'll give you wrong for that. I mean, final answer without working out. So what do you do? Without a calculator. So you think of your special angles. Let's see what you can do here. So cos 150 degrees. You check, where's 150 degrees? So you have 0 there, 90 there, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And you also have you remember the cost. Have you learned the cost rule? The cost, what have I done? The cost rule. So what do we have? I think I have something. Let's see here. I went back. Okay, so you have your cost rule there, which is cost rule implies that only cos is positive, sine positive here, and tan, and all trig ratio positive in that first quadrant. Now you ask yourself, where is 150? 150 is in that quadrant. Is cos negative or positive? It's negative. Cos. In this quadrant, we have 180 minus theta. So what can I minus from 180 to get 150? 30 degrees. So this whole thing is reduced to cos 30 degrees. How do I get that? I just say in this 150 is in there, cos is negative. What do I need to minus 180 to minus to get 150? I need 30. You go again, 225. Where's 225? In that quadrant. Is tan negative or positive? Stay positive tan. In this quadrant, we have what? 180 plus, because that's 180. From there, you get 180 plus. What do I need to add from 180 to get 225? It's 45 degrees. So, and you go there. Now, next one we have this, which is minus sine minus 60 degrees. And I can say, and negative theta is in fourth quadrant. If you rotate this way, so your negative theta is there. So negative 10 degrees, negative 30 degrees, negative 40 is in the fourth quadrant because you're rotating other way around. You're not going this way. Okay. So minus 60 is in the fourth quadrant. Then I'll have this is minus sine 60 degrees. Then what about cos 240? What do I do with this? Because 240, if I have a trig ratio with an angle bigger than 360, think about it. If I'm at this position and I rotate 360, I'm not changing the sign. I come back to the same position. If I minus 360, so you can minus 360 there. You can say cos, you can say 480 degrees minus 360. I think you get 120. You can just go there, minus as much as you want. If it's back, 480 minus 360, which is 120. So this is 120. So this is cos 120 degrees, because 360 plus theta is in the fourth quadrant. Then from there, I'm going to do something here. You have cos 30 degrees and sine 30 degrees. Okay. I want you to do this at home. Just test it. Check sine 5 degrees. 5 degrees. And put in the calculator and see what you get. Let me do it here. If I do this, sine of 5 degrees, see what I get? Let's do cos of 85. I'm saying cos 85. See what you get? I get same thing. So what happened is that from here you can change that in your special angle or that in a special angle. What is meaning? Actually, cos 30 degrees is the same as sine 60 degrees. I can cancel the two and I can write there because of the co-ratio. Okay, or change this into a special angle. But I know this is the same as that. I can cancel that. Then from there, what is left? You have tan 45, special angle, which is 1. I can reduce this. What is cos 120? Where's 120 degrees? 120 degrees is in that quadrant. And I can change cos 120, and it will be minus cos 60 degrees. Why? Because I have 120. So where is 120? In this quadrant. So what do I need to minus from 180 to get 120? I need 60, and cos is negative in that quadrant. And you can go use a special angle. You can say cos of 60, and cos of 60 is a half. You get negative. You get a half. So so this is positive. So I'll get negative a half. And if you simplify this, you get negative 2. Okay, guys. Now, before I can go through Abram, why I cancel this, I just want to make sure you guys understand. This is very important, that because if sine and cos, the two angles add up to 180, they cancel. Okay, because I can change the one. Okay. Thank you, Abram. I think we can take a break.
Yes,
yeah?
we should.
Okay, good.
And on that note, Mindsetters, remember the challenge question is up on the page, and some Mindsetters are already giving us their answers. So we'll see you guys after the break and see if you're correct. Welcome back, guys. Remember, your code for the Test Yourself question is posted on Facebook for that link, and your code for the momaths.org is 0JRN. But now, thank you guys for the questions that are coming through on Facebook. Let's get straight to some of these questions, and then maybe later we'll tackle some of the questions from the mindset.
Okay. Thank you, Abram. Okay, I hope you're there again, and you try and you try and you try, and we don't do maths by looking, we do maths by taking a pen and trying, and you try it again, you get it wrong, and you try it again, and the more you get it wrong, I promise you, the closer you are to the answer. Okay, let's see what I have here. I said I love trigonometry, and I say it again, grade 11 out there, 60% of a matric. It's trigonometry. If you find this difficult, you work and you work it until you get it right. You don't give up and you don't say, this is hard, I can't do it. If you say you can't do it, I mean, you really just take a pen and do it. Let's see what I have here. So the question is simplify without using a calculator the following expression. I mean, can I simplify this with a calculator? I don't think so. So what can I do? I can try to do the housekeeping there, do some manipulation, do some algebra there. So I can keep this, which is cos squared x, and I can keep this whole thing inside there. I can simplify this. The only way I can simplify this is LCD, which is sine minus 1 bracket and sine x plus 1. This is my LCD. Then now, ask yourself, what do I need there to get an LCD? I need this. So you'll have 1 multiplied by this, which is sine, which is reduced, which is sine, okay, which is, let me see, what am I doing? Which is sine. If I multiply this and this, I'll get sine x plus 1. You just kind of cross multiply. Multiply this, I'll get minus sine x minus 1. Then from there, what can I do? I can do housekeeping. This to cancel. The 2 cancel, then I still have my cos outside. Then I can write my bracket, which is this, and what do I get here? Sine x, I'll get 2 sine x over. I can try FOIL this. This times this, I'll get sine x squared. This times this, minus 1. Then from there, what can I do there? I mean, can I still do something? I mean, if you look at this, this, you have sine squared minus 1. What is that equal to? There's a certain identity, which is what? Sine squared plus cos squared is equal to 1. Sine squared plus cos squared is 1. Then if sine squared plus cos squared is 1, what is sine squared minus 1? Sine squared minus 1 is cos squared. Okay, out there. So that is cos squared. This whole thing is cos squared. So I'll write my cos squared outside, and I'll have my 2 sine x over. And what is sine squared? What is sine squared minus 1? It's cos x squared. And this cancel this, and I'll have 2 sine x as my answer. Okay, guys, great. I just use identity and use your algebra. You do some manipulation, and I get my answer as 2 sine x. Okay, great. Fantastic. Now, I'm going to look at the challenge question. Abram, do you have any answers on the challenge question?
I have lots of them.
Let's see what you have.
Okay.
Yeah.
Let's see the ones that are close.
The first one is find the first 3 terms of a sequence. What do you have there? The first 3 terms of a sequence.
Okay, give me a sec.
Okay,
please.
that's okay.
you know, it's Monday today.
Okay, great. Yeah, yeah.
Okay, refreshing.
Eh.
Sorry, I think I'll
No,
give
no,
you
that's
as you
fine.
go
Let
along.
me go through it, and,
Yeah.
later we can check who managed to get this. So you give an Sn. Can you see that Sn? When you substitute 1, you get the sum of the first term. If you substitute n2, you get the sum of the first 2 terms. If you substitute 3, you get the sum of the 3 term of the sequence. You're not getting how many terms, term 1, term 2, term 3, because now this is Sn, is the sum. The only way to do this, I mean, you substitute 1 there to get the first 3 term of a sequence, the first 3 term of a sequence, you substitute 1. If I substitute 1, I'll get 1 cubed, which is 2 times 1 cubed, minus 3 times n squared, and this is 1. You get minus 1. You substitute 2, you substitute 3, then you get your kind of your sequence. But I want to do this using a calculator. Okay, so let's see, how can I do this using a calculator? Take out your calculator there. I want to put this expression, so you go to mode. You have 2 for statistics and 3 for table. I can do my graph there. Okay, this is given as a function. I mean, then I'll put this, which is 2. I put 2. I want to put n there, but I can't put n. The only variable I have is x there. And to put x, can you see x? This x is red. To make this active, I need this alpha to make the red active. Can you see that? So I have 2x, which is the same. In this case, I'll use x because I don't have n. 2x cubed. Can you see that? Minus 3. I want x. Remember, to make x, the x is red, and to make this active, I press the alpha because it's red. I put x, then I put square there. Therefore, I have my formula, and I go to equal. If you get g at x, something like that, some calculator you get g at x, you keep on pressing equal until you get start. Now, remember, this is a sequence. I want the Sn, S1, S2, S3, S4, S5, and I want the 3 terms. So I'll start from 1. Where do I want to end? I'll write 5. I want the first 5 terms. I'll end with 5. And what is a step? Step denote, because I want 1, 2, 3, 4, 5. If I want 0.5, 1, 0.5, the gap between the terms, I'll use 0.5. In this case, I want 1, 2, 3, 4, 5. My step will stay 1, then equal to. There I get my term. I can write this down. If I write this down, I get minus 1. The first one is minus 1. Let me put this. The first term I get minus 1. Minus 1, 427. Then you can scroll down there if you want to go. Scroll down, 27, 80, and 80. I'll write the first 4 terms, and you get 80, the first 4 terms. Do you get something like this?
Yeah, there is one person who got those ones right. That's Sanil Mtambo. Minus 1, 4, and 27. The other one got them wrong. Minus 1, 5, and 23.
Yeah.
And the other one got them right also. Siyabonga Chiu, minus 1, 4, 27.
Okay, well done, Sanele and Siyabongile.
Siyabonga.
Siyabonga for that, for you trying hard. Remember, maths, you try hard and you try again, and no one must tell you you can't do maths. The only person who can tell you that is you. You try hard until you get it right. Let's see the second question. The second question now. Very important to read, guys. Find the formula for the nth term of the sequence. Find the nth term. No. I don't think this is correct, Gabriel. Find the first 3 terms of a sequence. The first 3 terms of a sequence, Siyabonga. Oh, I lied to you. This is not correct. It's not correct because this is the sum. Remember the formula. This formula gives us the sum of the sequence. The sum of the first term is that. And the sum for the second one, for the 2 terms is that, and for the 3 terms and fourth, we get that. So to get the first 3 term of a sequence, to get T1, first term would be -1. And to get this, because the first term is 1, the sum is 1, and if I have T1, 1, what is S1? The sum of the first term is still 1. If the sum for the second term is 4, the sum is 4. What is the T2? What is T2? Think about it. The first one is that you'll have that minus that. So you have 4 minus -1. You'll get 5. Just check you get something like this. It's -1, 5. And here is 27 minus that, which you'll get 27 minus 4, you get 23, and you will have 80 minus 27. Let's see here if you cancel. I cancel this. Now I want to work. I have that f at x. How do you get rid of this f at x? Mode 1. So I want 80 minus 27. I get 53. Those are the first 4 terms of a sequence because of Sn, guys. Very important. You get something like this, Abraham.
Yeah, there's one person.
What does she have?
-1,
Yeah.
5, and 23.
Great, Nkululeko. There, Nkululeko. This is great. -1, 5, 23, 5, 3. That's correct. The key thing, this is the sum of the term. The sum of the first term, the sum for the second, for the 2 terms, the sum for the 3 terms, and the sum for 4 terms. Now, we're doing the second, find the formula for the nth term. Let me see what kind of pattern is this. What I can do, I can say this minus this, 5 minus -1, I get 6. And if I say, I get 6. And if I say 23 minus 5, 23 minus 5, I get 23 minus 5, I get 18. And 53 minus 23, which is 53. 53 minus 23, I get 30. Okay, you get 30. So remember, if the first difference is the same, your pattern is linear, then I keep minusing again. This minus this, I get 6. And if I say 30, is that correct? 18 minus 30, I'll get 12, huh? 30 minus 18, I get 12. I get 12. There's something wrong here. Abram, can you check me that answer from Nkululeko? It's not -1, 5,
and
23, and?
He didn't write the other one.
The other one. He didn't
Yeah.
write the other one. Okay, so I think, let me do this. It's something, I don't think this is correct. So if I do this, I don't think what I wrote this is correct, but I'm sure this pattern is quadratic. If you minus and the second difference is the same, therefore your pattern is linear. Then what you can do now to find the pattern, you'll say 2a is equals to the difference, which is 6, and you'll say 3a, this is how I do it, plus b is equal to the second difference, which is 6 in this case, and now and a plus b plus c is equal to the first term, which is -1. Okay, so I think, guys, you can try to complete the problem on your own. Try to do the problem. If you have the first 3 terms, you can find the general term, and the general term in this case is quadratic. Do you have the final answer for that? Because I don't think we have time.
You can finish it.
I don't think we have time. Just check who got the final answer there.
All right, on B.
Yes.
I think you can come and look at these answers
Let's see.
quickly. There's one from Nkululeko.
Yeah. Okay, good. I think that's correct. There's something wrong. The 6th one is correct.
Okay, there's another one.
No, that can't be. The 18n squared can't be correct. So there's something wrong I've done that. Let's look at my first term. You still have time, Abram?
Just few seconds.
Just a few seconds.
Yeah.
Okay. Just check there. The first term, I said that minus that, I get 5. And to get this sequence, the first one is minus 5. The second one, I said 4 minus, I get 5. And this is 27 minus 4, which is 23. Is that correct? Which is 23. And the next term is, which is 80 minus 27, I think, which I got 53. Let me see, which is 80 minus 27, which is, I was correct, which is 53. Then what I can do, see here, let me try and find my first difference. My first difference, which is, see there, 5 minus 1, which is 6. 23 minus 5, which is 18. Then 53 minus 23, just cancel that. 53 minus 23, which is 30. Then from there, if I minus these two,
You know what the mindset say?
yes?
They say your 18 minus 6
My?
is 12.
What?
So it's quadratic.
Where? My?
Your 18,
18.
minus 6,
Yes, is?
you get 12.
I get 12. I get 12. Thank you. That's my mistake
So they
there.
say it
It's
is
it's quadratic. Thank you. So I get 12. So from there, I can fix it. Let me fix this. So what is happening there is that 2a is 12. Therefore, a is 6. Then from there, you can say 3a plus b is 3a plus b is equal to the second difference, which is 6. Okay? Then we have a. We have a, which is 6. So you have 3, 6 plus b, which is 6. And this is 18. Therefore, b is 6 minus 18. Therefore, b is negative 12. Then from there, we have that a plus b plus c is negative 1, the first term. So this is negative 1, and a is 6, b is negative 12, b negative 12 there. So I have my negative 12, c minus 1. If I add the 2, I get minus 6, plus c is minus 1. Then I can move 6 this side. I get c is minus 1 plus 6. Therefore, c is 5. Then the nth term is tn, is a, n squared plus bn plus c. bn plus c. So let's look at a. Then you just substitute your a. For a, we have a is 6, and b is minus 12, and c is 5. Then this is our general term. Okay, great. We have something like this. Great, great,
Nice
guys.
one. Yes,
Yeah.
Lucky Ratao just said it on Facebook. No wonder why they call it a challenge question. But otherwise, thank you, sir,
Yeah.
for helping us today. And thanks to the Mindsetters for tuning in and helping one another on the page. We really appreciate. Until next time, thank you, sir.
Great.
Right. Peace, your Mindsetter. We love you.